So now, let's have the examples for us to further understand the different laws of logarithm. So we need to use the properties of logarithm to expand each expression in terms of the logarithms of factors. First example, we have log ab squared. So we have a times b squared here. So meaning we are going to use a product rule. So we have equals to log a. So the first value, the first variable. So this example is an example of common logarithm wherein our base is 10. So we do not write 10 as your base. So we have log a plus log b squared. So this a and b squared. Next, we can also use another property to log b squared. So the power rule, that will be equals to log a plus. So power rule states that you can bring down this exponent or the power of your base b to be a scalar value to be multiplied to your logarithm. So we have 2 times log b. So this is your answer, log a plus 2 log b. So this is the expansion of this log a b squared. Next example, we have log base 3 power of 3 over x raised to 3. So we have here a quotient for your power and again a power rule, exponent to your power. So we have equals to 3. So first, let's use the power rule. So bring down this 3 here to be multiplied to your logarithm. So we have 3 times log base 3 and then 3 over x. Then now let's use quotient rule to log 3 over x. So we have 3 multiplied by log base 3 of 3. So first, the numerator minus the log 3 of x, which is our denominator. So when we expand this, we have, when we simplify this, we have 3 times 1 minus log 3 of x. How it becomes 1? So log 3 of 3 is equals to 1. Meaning, since our power here is the same to your base, that means the exponent is equals to 1. And when we distribute 3 times 1, that is equals to 3, then 3 times negative log of base 3 of x. So we have negative 3 minus 3 log base 3 of x. So this is our expansion to this logarithm expression. Next example, number 3, we have ln of x multiplied by x minus 5. So we have here a product and our given logarithm is a natural logarithm. So our solution, we have equals to ln x plus, so we can apply here the product rule. So ln x plus ln of x minus 5. So that is the expansion of this logarithmic expression. So let's try to have an example. Now, let's use the properties of logarithm to condense. So for the first examples, we expand the logarithm expressions. This time, we need to condense it or simplify in single logarithms. So first example, we have log 2 plus log 3. So the basis here, again, is 10 since we do not write it. So this is a common logarithm. So when we write it in a single logarithm, it will become the log 2 times 3. So a product rule. So because we have plus here and same basis. Then log 2 times 3 that 2 times 3 that is equals to 6. So we have log 6. Next, let's have 2 ln x minus ln y. So we have here minus, so we can apply the quotient rule. So we have 2 ln x minus ln y equals to ln, first let's apply the power rule. So we can write x raised to 2. So we have ln x squared minus ln y. Then apply the quotient rule, we have ln x squared over y. And last example, we have log 5 x squared minus 3 log base 5 of x. So same basis, and we have a minus here, and we have x squared as your first power with an exponent 2. Then it will become equals to log base 5 x squared minus. So we have 3 here, so we can write it as the exponent of our x. So log 5x cubed. Then we have log 5. So since we have minus here, then we can use quotient rule. So log base 5 x squared. So we have x squared here divided by x cubed. So it's also equals to, so x squared divided by x squared. So we have same base. Then exponents should, the law of exponent, we have 2 when we have division, and same basis, we just subtract the numerator and the denominator exponent. So 2 minus 3, that is negative 1. So we have an x raised to negative 1, so we can write it in the denominator, so x raised to 1. So the value of your power will be equals to 1 over x. So the answer, so we have log 5 of x raised to negative 1. So that is equals to negative log base 5 of x. So we bring down this negative 1 to this to our as a scalar value to be multiplied to our logarithm. So negative log base 5x. So this is the answer, or single logarithm of this example. So now, again, fourth example, we have 2 minus log 5. So we have common logarithm involved here, and 2 can be equals to, when we transform it in a logarithm, we have log 100. How it becomes log 100? So base 1, our base here is 10. So when we raise 10 to 2, that will mean 10 squared. 10 times 10, that is equals to 100. So that is our power here. Then minus log 5. So since now we have same basis, which is 10, the value will become log of 100 over 5. So 100 over 5, that is 20. So the answer is log 20. So the answer, single logarithm here, is equals to log 20. Now, last, we have the change of base formula. So we left a, b, and x, be the real number here, with your a should not be equals to 1, and also your b, which is the base. So this property is log b of x, which is equals to, when we have to change the base, when we need to change the base into a, so the base should, from b to a, it will become to log base a of x divided by the log base a again to b. So your base b will become the power to the denominator. So let's have an example to that. Examples. So use the change of base formula to write the following logarithms expressions to indicate to the indicated bases. Then let's evaluate. So first example, we have log base 8 of 32. Then we need to change to base 2. So from 8, base 8, we need to change it to base 2. So how? So log 8 base 8 to 32. So let's use the formula log a. So our a now, the base should be 2. So log 2 of 32, so that is our x, the power first, then over or divided by to log 2 to 8. So the base now becomes the power to our denominator. Then log 2 32 is the same to log base 2 to 2 raised to 5. So 2 raised to 5 is equals to 32. And log 2 of 8 is equals to log base 2 to 2 raised to 3. So we have same bases and same bases to your power. So that would mean we have 5. So when we bring down this 5, then 5 times 1, that is equals to 5, divided by log base 2 or 2/3. This denominator is equals to 3. Because when we bring down this 3, we'll have log base 2 of 2. Then log 2 of 2 is equals to 1. Then 3 times 1, that is equals to 3. So the answer to log 8 of 32, when we change it to base 2, will become 5 over 3 or 5/3. Second example, we have log base 243 of 1 over 227. So change to base 3. So from 243, let's change the base to 3. So here is the solution. We have equals to log base 3, 1 over 27. So 1 over 27 is the power of our given over log base 3, 243. So the base here becomes the power. So this will become equals to log base 3 of 3 raised to negative 3. So our 1 over 27 is also equals to 3 raised to negative 3. So we have 1 over 3 raised to 3 here. So 3 raised to 3 is equals to 27. So when we bring to the denominator, bring to the numerator, we'll have negative exponent. So we have in the denominator log base 3 of 3 raised to 5. So 3 raised to 5 is equals to 243. The power 243, we have 3 times 3, 9 times 3, 27 times 3, that is 81 times 3, that is 243. So since we have same bases here, then the base is the same to the base of the power, then we will bring down the value of the exponent. So we have negative 3 over 5. So same principle, same properties that we've used to the first example. And last example, we have log base 25, power of 1 over square root of 5. So this time we need to change to base 5 from 25 to 5. So here's the solution. We have log base 5, power of 1 over square root of 5, all over log base 5, power of 25. So 1 over square root of 5 is also the same to 5. Square root of 5 is also the same to 5 raised to 1/2. So this exponent is 1/2 when we recall the radicals and the indices. So since it's in the denominator, when we bring it to the numerator, it will become negative exponents. So for the denominator, we have log base 5, 25, and 25 is equals to 5 raised to 2. So same basis to numerator, denominator, and our basis to the power is the same, which is equals to 5. Now let's bring down the negative 1/2 to our numerator and then 2 to our denominator, and negative 1/2 divided by 2, that is equals to negative 1/4.